Let us continue. Atomic structure, hydrogen spectrum. In the hydrogen spectrum, we are taking hydrogen gas. Hydrogen gas we are taking. In the hydrogen gas, hydrogen molecules present. Due to passage of current, hydrogen molecules dissociate to give hydrogen atoms. Hydrogen atoms contain electron. Due to passage of current, the hydrogen atom electrons are in a different excited level, different excitation levels, okay. Different excitation levels means different higher energy levels, different higher energy levels. So we supplied current, that means we supplied quanta. Due to that, we made hydrogen electrons to come to higher energy levels. Therefore, stability of electrons became low. Stability of electrons became low. This is due to why we made it. We passed current, so we made hydrogen molecules to convert into hydrogen atoms. Since we supplied quanta, we made electrons of hydrogen atoms to go to different excitation levels. Since we passed radiation, the electrons of hydrogen atoms are in different higher energy levels. So due to us, stability of electrons become low. So due to us, these many things happened. Due to us, these many things happened. Now, what electrons of hydrogen atoms will do for this? Due to us, we made hydrogen electrons to come to this situation. We made hydrogen electrons to come to this situation. What is the response of hydrogen electrons? Sir, hydrogen electrons will go for de-excitation. Hydrogen electrons will go for de-excitation. De-excitation means emits radiation. Due to that, hydrogen electrons comes to lower energy level. Okay. Now you say that hydrogen electron comes to lower energy level means all the electrons will come to same lower energy level, or in the lower energy level also different lower energy levels will be there. What shall we say? Now lower energy level we are saying. In the lower energy level means it is only one level or different levels. Lower energy level means it is only one. It is only one level or different levels. What shall we say? Lower energy level means. Shall we say lower energy level means it is only one level? Only one level is called lower energy level. Okay, you are saying that in the lower energy level also different energy levels are there. Sir, in the lower energy level means different energy levels are there. You are saying, sir, correct. Now here hydrogen electrons are in different higher energy levels. They are going for de-excitation. They are emitting radiation, therefore they are coming for lower energy level. Now they emitted radiation, that radiation comes out. Sir, that radiation comes out. Now that radiation is having wavelength. How many wavelengths will be there? Only one wavelength shall we say, or many wavelengths shall we say? What shall we say? Here this radiation is having wavelength. This wavelength will be only one value or many values. What shall we say? Only one value will be there or many values will be there. What shall we say regarding this radiation? Now see that hydrogen gas contains molecules converted into atoms, electrons contains like this. So you are saying that radiation contains many wavelengths. Sir, radiation contains many wavelengths. At that point we got an idea. Sir, okay. Radiation contains many wavelengths. Sir, what wavelengths means? Hydrogen spectrum gives that. Hydrogen spectrum gives that. In the hydrogen spectrum, ultraviolet region contains Lyman series spectral lengths. Balmer series contains visible region spectral lengths. Like this, near infrared, infrared, far infrared, Paschen, bracket, fund, like this series are there. So like this happened. So this is about hydrogen spectrum. Now, this hydrogen spectrum is explained by Niels Bohr. This hydrogen spectrum is explained by Niels Bohr by introducing some postulates. So, what are the postulates of Niels Bohr? That model we will see. Then we will come back to hydrogen spectrum. How Niels Bohr explained hydrogen spectrum we will see. So now we will take postulates of Niels Bohr model. Postulates of Niels Bohr model we will see. Postulates of Niels Bohr model we will take. So in the postulates of Niels Bohr model, Niels Bohr says that in the atom, nucleus is a sphere. Nucleus is a sphere which is present at center of an atom. Which is present at center of an atom. Next, electrons revolve around the nucleus. Electrons revolve around the nucleus. In certain specific circular paths. In certain specific circular paths called orbits. So regarding Niels Bohr model, you see that electrons revolve around the nucleus in certain specific circular paths called orbits. Certain specific circular paths called orbits. Sir. So which circular path we have to consider? For that, for orbit, which orbit we have to consider? Which circular path we have to consider? For that, what is said? What is said in the sense, orbit angular momentum is says. Orbit angular momentum is says. That is equal to nh by 2 pi. It gives orbit angular momentum is nh by 2 pi. Which circular path is possible? Or which orbit is possible? For that, what he is saying means angular momentum of the possible orbit is nh by 2 pi, where n is equal to whole number 1, 2, 3, etc. 1, 2, 3, etc. Okay. So n is a positive integer. N is positive integer. So if we take n is equal to 1, it is called a first circular path. It is called the first circular path possible, for which angular momentum is how much means h by 2 pi. H is called Planck's constant, pi is constant. So n is equal to 1 means first circular path for which h is equal to 2 pi. Sir. So now we will consider it is the nucleus. Now as per Niels Bohr model, first circular path we will take. It is the first circular path. For this circular path, angular momentum. For this circular path, orbit angular momentum is h by 2 pi. For this circular path, orbit angular momentum is h by 2 pi. Next, we will take a second circular path. It is a second circular path. For this second circular path, orbit angular momentum is h by pi. It is a second circular path. For this second circular path, orbit angular momentum is h by pi. It is the second circular path. It is the first circular path. This is the first circular path. For this angular momentum is h by 2 pi. It is the second circular path. For this angular momentum is h by pi. Now, in between first and second, in between this first circular path and second circular path, there is no other circular paths. Okay, it is the first circular path. It is the second circular path. in between 1 and 2. Okay, in between so in between 1 and 2, first circular path and second circular path, there is no other circular paths, no other circular paths, no other circular paths for electron. Okay, it is a Bohr's point of view. So that Bohr's what he is saying, see, electrons revolve around the nucleus in certain specific circular paths. How he is saying, see, certain specific circular paths. Certain specific circular paths only possible. So as per Nilsboro model, he says this point is very, very important. Electrons revolve around the nucleus in certain specific circular paths. Around the nucleus, we can draw many circular paths we can draw. Which circular paths possible means the circular path which is having angular momentum nh by 2 pi, where n is equal to positive integer, where n is equal to positive integer. So this we are saying that this is first circular path means for this angular momentum is h by 2 pi. This is second circular path we are saying means for this angular momentum is h by pi. Between 1 and 2, between 1 and 2, no circular path is possible. So in between 1 and 2, in between 1 and 2, no circular path is possible. Okay. Sorry, between nucleus and 1, between nucleus and 1, no circular path is possible. No circular path is possible. That means electron will not be present at this place. Electron will not be present between nucleus and first circular path. Between first circular path and second circular path, electron will not be present. That is Bohr's point of view. Bohr's thought in that way. Bohr's thought in that way. Whether it is correct or wrong, that we have to see as per modern theory, modern atomic theory. Modern atomic theory means quantum mechanics. Based on quantum mechanics only we can come to the conclusion. That means at present we are following quantum mechanics concept. Okay, this is Bohr's model in the sense, Bohr's model in the sense his point of view, his thought. Okay, is thought, that's all. It is not a final one. It is not final one. As per Bohr's model we are saying like this. Okay, so as per Bohr's model, between nucleus and first circular path, electron is not present. Between first and second circular path, electron is not present. Electron is present only in first circular path, otherwise only in second circular path, otherwise only in third circular path, like this. This is Bohr's model. Therefore, he is saying that this circular path is what? Stationary. This circular path is what? Stationary. Why is stationary? Because it is having particular angular momentum. It is having particular angular momentum. Okay, therefore it is stationary. So that this orbit is called a stationary orbit. This orbit is called what means stationary orbit, we can say. It is a Niels Bohr model point of view. Then this Niels Bohr model, what he is saying means when electron travels from lower energy level to higher energy level, when electron jumps from lower energy level to higher energy level, it will absorb energy. It is we will take it is first level. It is first level. This we will take a second level. This we will take a third level. Like this, how many levels possible means infinity levels possible. Like this, how many levels possible means infinity. When the electron jump from first level to third level, what it will do means it will absorb energy. It will absorb energy. Okay, when electron jumps from first level to third level, what it will do means it will absorb energy. When electron jumps from lower energy level to higher energy level, it will absorb energy. So now we will take the higher energy level, we will give us a E2 symbol. Lower energy level we will give us E1 symbol. Difference in energy levels will be how means in the multiples of quanta. H nu means quantum. H nu means quantum. N means number of quanta. Number of quanta. N is called number of quanta. H nu is called quantum. H nu is called quantum. N is called number of quanta. E2 is called higher energy level. E1 is called lower energy level. Difference between higher energy level and lower energy level is called number of quanta. Number of quanta is okay. That means Bohr's considers Niels Bohr model considering that Planck's quantum theory, because Planck's quantum theory only considered quanta, no? Planck's quantum theory only proposed quanta, no? So Niels Bohr model considering which one? Planck's quantum theory. Niels Bohr model considering Planck's quantum theory means as per Bohr's point of view, as per Bohr's thought, electron is a particle, or electron is a wave, or electron is a cloud. In which way he thought such that he considered a black body radiation. Because H nu means quantum, H nu means quantum, NH nu means number of quanta. Number of quanta in the sense black body radiation postulates, Planck's quantum theory postulates. So Niels Bohr considering Planck's quantum theory postulates means Niels Bohr thought of electron, Niels Bohr view of electron, Niels Bohr viewing electron in what way? Niels Bohr considering electron in what way? Whether Niels Bohr considering electron as a particle or as a wave or as a cloud, in what way he considered? In what way he considered? And also you see that Niels Bohr saying that electron revolves around the nucleus in a certain circular path. That means he is not saying that around the nucleus circular path will be there, over that electron is traveling. Like that he did not say. It is a nucleus, nucleus is a sphere, electron is traveling around the nucleus, that traveling path is certain circular path, like that he says. The electron is traveling around the nucleus, no? Electron is traveling around the nucleus, that path is what way? That path is which manner will be there means that path is a specific circular path. That circular path is having constant angular momentum, that is nh by 2 pi. That is a view of Bohr's. How Bohr is viewing the electron? How Bohr viewing the electron means electron is traveling around the nucleus. That traveling path, how it will be there means circular path, specific circular path, stationary path. That stationary path will have that electron will have particular angular momentum. This electron will have a constant angular momentum till we do not disturb. Constant angular momentum. That constant angular momentum is how much means nh by 2 pi. If you do not disturb, then this electron is having constant angular momentum. That means its energy is constant. Its energy is constant. Energy of electron is constant till we give disturbance. If you do not give disturbance, how the atom will be there, how the electron will be there means the electron will have constant energy, its own energy. Electron will have constant energy. Electron will have constant angular momentum. So electron is making a particular, specific, stationary, constant circular path. Okay, so this is having a specific orbit. The orbit is specific, that is circular path. This is a Bohr's view. That's all. Bohr viewing electron in this way. Bohr's view. It is a single man view. That's all. But quantum mechanics is not like this. It is a mixture of all the points quantum mechanics considered and proposed. So till now we are accepting, we are following which one in the sense quantum mechanics concept, but not Bohr's concept. Bohr's view is like this. Bohr's view is considered in quantum mechanics, but quantum mechanics is not only Bohr's model. So, quantum mechanics is based on many models. So Bohr's point of view is like this. So as per Bohr's point of view, electron path is circular means Is he considering this is as a two-dimensional or three-dimensional? Electron path is circular path, he said. Circular path means whether that is two-dimensional or three-dimensional. Which shall we say? So that is a two-dimensional one. His point of view, his view is like this. Sir. Now he said this is a higher energy level. E2 means higher energy level. E1 means lower energy level. Difference in these two energy levels is n number of quanta. Sir. When electron jump from higher energy level to lower energy level, it will emit radiation. That is Bohr's another point. Okay, it is a nucleus of an atom. Then it is the first level. It is the first level. It is the second level. It is the third level, and so on, up to infinity. Up to infinity. Now, when the electron present at suppose third level, when electron present at third level and it is jumping to first level, suppose it is jumping to first level. When the electron jump from higher energy level to lower energy level, okay, then when the electron jump from higher energy level to lower energy level, it will emit radiation. It will emit radiation. So, now higher energy level we will take as E2. Lower energy level you will take as E1, and difference is how much means n number of quanta. H nu is called quantum. H nu is called quantum. This H nu is called quantum. N is called number of quanta. N is called number of quanta. So this emitted radiation is containing n number of quanta. This emitted radiation contains n number of quanta. That means we will take only one electron we will take now. Correctly, only one electron. Only one electron. Only one electron if you take higher energy level is E2, lower energy level is E1. The difference is h nu, which is one quantum. Which is one quantum. Only one electron if you take one quantum. So the difference in energy levels is equal to quantum. Is equal to quantum. This emitted radiation contains this quantum. This emitted radiation contains this quantum. These are the postulates of Nilsboro model. So what are the let us recollect the postulates of Nilsboro model. So one point is electron is revolving around the nucleus in certain circular path, called orbit. Electron revolves around the nucleus in certain circular path called orbit. Orbit is having angular momentum. Angular momentum of the orbit is nh by 2 pi. nh by 2 pi, where n is equal to positive integer, it will take only whole number. Then when the electron present in particular circular path, when the electron is in a particular circular path, its energy is constant, therefore orbit is a stationary. Orbit is a stationary orbit, and energy of electron is constant, therefore this energy level is called a constant energy level, which is saying that main energy levels. So main energy levels means n is equal to 1, n is equal to 2, n is equal to 3, and so on. Okay, then when electron jumps from higher energy level to lower energy level, it will emit radiation. When electron jumps from lower energy level to higher energy level, it will absorb radiation. That difference in energy levels, higher energy level minus lower energy level, is equal to nh nu. Okay, otherwise if only one electron, if we consider h nu, we can say only one electron in the sense h nu. nh nu we need not say, only one electron in the sense h nu set. So E2 minus E1 is equal to what means h nu. So Niels Bohr postulates, first postulate is certain circular path, electron revolves around the nucleus in certain circular path called orbit. Orbit is having angular momentum, that is nh by 2 pi, n is equal to 1 to 3, etc. And in the this orbit is called a stationary orbit. Stationary orbit means its energy is constant, its angular momentum is constant. Then electron present in this level means that is having energy, that energy is called that energy, and this level is called main energy level. Electron will emit radiation when it is jumping from higher energy level to lower energy level. Next, electron absorb energy when it jumps from lower energy level to higher energy level. The difference in levels, that means higher energy level minus lower energy level is equal to quantum, that is h nu. This is postulates of Niels Bohr model. So, using these postulates, Niels Bohr explaining hydrogen spectrum. Niels Bohr explaining hydrogen spectrum. So, how Niels Bohr explaining hydrogen spectrum, that we will see. Before seeing that one, in the Niels Bohr model, deriving gives some derivation. What are the derivation means? One is what is the radius of this orbit? What is the radius of this circular path? And electron present here means what is the energy of this level? What is the energy of this level? And electron is revolving around the nucleus means with a certain velocity. What is that velocity? What is that velocity? These derivations and all Niels Bohr gave. So Niels Bohr gave what are the derivations for electron means electron is making certain circular path. It is having radius. What is the radius of circular path? That he gave derivation. Then electron is present, suppose in this level, then it will have energy. What is the energy of electron? What is the energy of this level? What is the energy of this main energy level? That he gives. Then he says that what is the velocity of electron? Then he explained hydrogen spectrum. He explained hydrogen spectrum. So, now we will see derivation. We will see. Then we will go for a hydrogen spectrum explanation. So now first we will see radius of orbit. Derivation for a radius of orbit. Radius of orbit will take. So now he considered to say radius of orbit. He has to consider the species. He has to consider the species. Which species he considered means one is hydrogen atom. Another one is what means hydrogen-like species. Hydrogen-like species. Another one he considered hydrogen-like species. How do we say that he said he considered hydrogen-like species means he mentioned about one electron, not many electrons. He mentioned about one electron, not many electrons, therefore hydrogen-like species. Hydrogen atom means that contains one electron. Hydrogen atom means that contains one electron. And hydrogen-like species means what? Hydrogen-like species means it is just like hydrogen. That means how hydrogen is having one electron, like that these also have one electron. Okay, so hydrogen atom is having one electron. Hydrogen-like species also having one electron. So now we will see regarding hydrogen-like species. We will see. Now we will take helium atom. Helium atom atomic number 2, so it is having 2 protons. It is having 2 protons. 2 protons in the sense relative charge of proton. Relative charge of proton is +1. Therefore, 2 protons means +2. Then atomic number 2. Number of protons is equal to number of electrons in an atom. So, helium atom is having 2 electrons. So, electron relative charge is -1. 2 electrons means -2. Net charge is 0. So, atom is neutral. Atom is neutral. Now, we have to make number of electrons to be 1 electron, because we want to convert this into hydrogen-like species. We want to convert this into hydrogen-like species, so we have to make number of electrons as 1 electron. So what shall we do remaining electrons? Remove that remaining electrons. So how many electrons shall we remove? Remove 1 electron. So from helium atom, we are removing 1 electron. If we remove 1 electron from helium atom, then how many electrons will be remaining means 1 electron is remaining. Regarding protons, we are not touching anything. Regarding protons, we are not doing anything. So relative charge of proton is +1, 2 protons therefore +2. Relative charge of electron is -1, 1 electron therefore charge is -1. Net charge is +1. That +1 we will give to this. So we will write He plus. So this He plus contains this He plus means it is having net charge. Therefore it is called ion. This He plus is having 1 electron. Therefore it is an example of a hydrogen-like species. Hydrogen-like species. Now you say Li, lithium we will take. Its atomic number is 3. It is having 3 protons. It is having 3 protons. It is having 3 electrons. Now you convert this into hydrogen-like species. You convert this into hydrogen-like species. So what you will get? You see, you tell us, you convert this into hydrogen-like species and tell us. Next we will take beryllium, atomic number 4. Atomic number 4 means this is having 4 atoms, 4 protons, and it is having 4 electrons. Okay, convert this into hydrogen-like species. If you convert this into hydrogen-like species, what formula you will get? You see. So you are saying that for lithium case, hydrogen-like species is Li2 plus. You are saying this is correct. Convert for beryllium case. You are saying that for beryllium case, that is Be3 plus. You are saying hydrogen-like species is Be3 plus. Now we will take boron. Boron atomic number is 5, so it is having 5 protons and 5 electrons. Convert this into hydrogen-like species. What you will get? You will see. Convert that into hydrogen-like species. So you are converting this into hydrogen-like species. So we came to know that which are hydrogen-like species. So hydrogen-like species means they will have 1 electron. Okay, they will have 1 electron. So now we will see. First we will take hydrogen atom. For hydrogen atom, we will say atomic number is 1. So it is having 1 proton. Hydrogen atom atomic number is 1. So it is having 1 proton. And number of protons equal to number of electrons for an atom. So it is having 1 electron. Hydrogen atom is having 1 proton and 1 electron. Now we will take He plus. He plus is having, see that He plus is having 2 protons in the nucleus, but 1 electron. It is having 1 electron. It is an example for a hydrogen-like species. So for hydrogen-like species, we can say He plus, we can say its a nucleus. This nucleus contains 2 protons, but this ion is having 1 electron. In that way, hydrogen-like species, another example is what means Li2 plus. Hydrogen-like species, another example is what means Li2 plus. Li2 plus is having 3 protons. Li2 plus is having 3 protons, but it is having only 1 electron. Li2 plus is having 3 protons, but it is having only 1 electron. Next example for hydrogen-like species is Be3 plus. See that this nucleus contains 4 protons. This nucleus contains 4 protons, but it is having only 1 electron. So hydrogen atom means number of protons 1 in the nucleus. Hydrogen-like species means what is the number of protons in the nucleus? What is the number of protons in the nucleus? Do you say 1 or it need not be 1? Greater than 1 do you say? Hydrogen atom, if you take its nucleus contains 1 proton. Hydrogen atom nucleus contains 1 proton. What about number of protons in the nucleus of hydrogen-like species? It should be 1 or greater than 1 depending on the species nature. Number of protons in the nucleus of hydrogen-like species, shall we say it is equal to 1? Shall we say it is equal to 1? Or shall we say greater than 1, which depend on, this value depend on that nature? What shall we say? Now, hydrogen atom nucleus contains 1 proton. Hydrogen atom nucleus contain 1 proton. Okay, you are correct. Hydrogen-like species means that nucleus contains how many protons means you are saying greater than 1. That value depend on that nature means if you take helium 2 protons, if you take beryllium 4 protons, like that you are saying. Sir, you are correct. Next, hydrogen atom is having 1 electron. Hydrogen like species means hydrogen atom is having 1 electron. Hydrogen atom is having 1 electron. What about number of electrons of hydrogen like species? Number of electrons of hydrogen like species is always 1 or greater than 1. That value depend on nature of that. What do you say? Hydrogen like species. Hydrogen atom means number of electrons is 1. Hydrogen atom means number of electrons is 1. What do you say about hydrogen like species? Hydrogen like species means how the number of electrons will be there. Number of electrons of hydrogen like species is always 1. Okay. You are saying that number of electrons of hydrogen like species is always 1. So we came to the conclusion that hydrogen like species means number of protons in the nucleus is greater than 1. That value depend on its nature, but number of electrons is always 1. So conclusion is hydrogen like species means number of electrons is 1, but number of protons is not 1, it is greater than 1. That depend on its atomic number. That depend on that atomic number. That is the conclusion, sir. So continuation we'll see. Now we will take a hydrogen atom. We will take for a hydrogen atom nucleus. We will take the nucleus contains 1 proton. 1 proton means that relative charge is +1. That +1 I will write it. Relative charge is +1. So that relative charge is +1. That I will write in the form of plus E. I will write. So hydrogen atom I have taken that nucleus contains 1 proton. The nucleus contains 1 proton. For 1 proton relative charge is +1. So I have written +1 in for the nucleus. Instead of +1, I have written plus E. Is it correct? E means electron only, no? Then why do we write plus E for hydrogen atom nucleus? See, hydrogen atom nucleus contains 1 proton. Proton is having positive charge, okay, plus. Relative charge of proton is 1, okay, 1. So hydrogen atom nucleus contains 1 proton, 1 proton. So therefore we have written like this. So what you are saying means why did we write plus E means you are saying that charge of proton and charge of electron are equal but opposite in sign. Magnitude of charge of proton and magnitude of charge of electron are equal, only opposite sign. Therefore only we have written E. You are saying that is correct. So the nucleus of hydrogen atom charge we can write plus E. E indicates electron only, no doubt, but charge of electron and charge of proton magnitude is same. Magnitude of charge of proton, magnitude of charge of electron is same. That's why we have written E. We have written. Okay, so plus indicates positive charge, E indicates charge of electron and charge of proton remain same. Magnitude remains same. Sign is opposite. Sorry, okay. Now we will take He2 plus He plus we will take. It is hydrogen like species. Its atomic number is 2. So this atomic number is 2. So it is